I want to show you how this helps us determine information about a triangle. In this second triangle, we know the length of all of the sides, and we don't know what the angle up at the top is. We know that it's represented by theta, but we don't know the value of theta. And the equation we have for sine of theta is sine theta equals 0.7456. So that's great. We know the ratio, but we don't know what theta is. To determine what theta is, we have to effectively move sine over to this side, and when we do that, we end up getting theta equals sine inverse of whatever the ratio was. So 0.7456. And we can use our calculator to calculate this value. Let me show you how to do that. To calculate the sine inverse of a number, we're going to have to make sure that our calculator is in scientific mode. I'm going to punch in the ratio first, so 0.7456. I'm going to click on the trigonometry dropdown. I can see sine, cosine, and tangent, but I want to find sine inverse, cosine inverse, and tan inverse. And we do that by clicking on the second button. And now I can click on sine inverse. And my calculator will tell me that the sine inverse of 0.7456 is 48.2106602.9. That means that angle theta is 48.21 degrees. If I've done everything correctly, when I use the cosine ratio and the tangent ratio, I should get the same value for theta. Let's check it out. From our calculations, we have cosine of theta is equal to 0.6667. So let's pull our calculator up and see what we get for cosine inverse of 0.6667. So I'm going to type in my ratio first, 0.6667. I'm going to click on the trigonometry drop-down and second function, and then cosine inverse. And I end up getting 48.189. So rounded to one decimal place, I get 48.2 degrees. When I checked using the tan ratio, I got 48.03. Pretty close. And I think probably the error or the difference that we have in this last case probably stems from any kind of rounding that we had in the diagram.